For this problem, we're asked which formula describes the sequence a n, this should be a subscript n, written like this, is equal to all of this, for n equals 0, and it goes on to infinity. Now, what we're saying here is that this is a to the 0th, this is a to the 1, a to the 2, a to 3, and so on and so forth. And we're going to use some kind of pattern recognitions here. So for the first thing we have is a 1, right? And then we have a 2, and we have a 9. Well, let's try to simplify these down a little bit. So we know to solve this, we can just say that there's a 1 in here. Now this, let's see, it has, just like this one, it has a 1, but we have a 1 to add to it. And this one, we have a 1 here, and then we would need to add 8 to it if we were to do this, right? And then let's look at the next one. We have 28, and we would add 1 to 27 to get to this. And now let's do one more, so 65. And that's a really bad 65, but we need to add 1 to 64 to get to this. And I'm already seeing a kind of pattern. So this is our first pattern, that we add 1 to everything. The next is, it looks like we take the number we're at, because remember, this is index 0, this is index 1, this is index 2, 3, 4, and so on and so forth, because of what we labeled right here. Now, this 8 is going to be 2 cubed. This 27 is going to be 3 cubed, and this 64 is going to be 4 cubed. So we do have a pattern here, and it would work for the rest of them as well. It is pretty good to check it though. We won't check it here, we'll just assume that it works, but it is, again, good to check. So we can see that this correlates with our index, what index we are at for each of them. So we can say that it's going to depend on our number cubed plus 1. So the formula for a of n is going to be n cubed plus 1.